the concept of absolute value, but just understanding that you're moving 4 degrees or 4 pounds or $4 in one direction, and the issue comes from right or left, increasing or decreasing.
Yeah, thank you. And I think you just made clarification. So I just opened up ANET, right? So once again, I'm here to kind of just model those resources. And so ANET, you're right. I mean, it just says apply properties of operations to add and subtract rational numbers, right? Is that NSA 1B? No.
That's 1C. You're looking at 1C.
So what is?
1D.
Yeah, NSA 1D. But am I supposed to be looking at B? Is that right? Maybe B? So maybe I just screwed up on here. But I think the point being I don't even see 1B.
It says 7 NSA.
Well, 1B and 1D go together in a sense. You can't do one without the other.
Okay. Okay. It makes sense. And so what I want us to get into is, and I'm just pause in our process right now. What we're trying to do, and I hope that you guys as a 6th grade and an 8th grade teacher are thinking about where does this standard fit at the 6th grade level? Because at the 6th grade level, and the reason why I brought up absolute value is that it's going to come and at some point in time. And so we need to have students have a true understanding of that, especially because they have to be prepared for 7th grade to deal with this. And that's why I brought that up there. And so we have tons of resources that'll help us kind of connect that. So when we're doing data days like this, I think the best thing to do is to pull out my achievement network. On these, there's that coherence map. And so, I don't know, I'm going to click it on the video so people can see, but at the bottom there's that coherence map. And whenever you're on a standard, like it'll truly break you apart. So if we're sitting at the 7th grade standard, I can click on it now and it's NS, and then there's A1. I can map the standard, and when I do that, as you guys all know, or I think we showed you before, gosh darn it, it will like pull the back standard for 5th grade, and it keeps going back. So you guys, when they're sitting here, I would just encourage you to look ahead and look behind of the standard they're talking about, because it'll really give you a deeper sense. And then we can find gaps, right? Because as great as this is a exemplar, I bet both of you two could have written a better exemplar than what you're seeing right here.
Sure.
You know what I mean?
Sure.
And I think that what we want to get to is a point of like, we're going to write this major exemplar, be ready for that, write that thing up so that when you're walking around and giving feedback, you know where you want it to be, and you're just and you're kind of helping and supporting students to get to that. But this is a good student exemplar.
Well, we had decided do you want this to be like completely baseline data, or do you want me to do any teaching at the table?
Right.
Seriously.
No, yeah.
Because I kind of sat there and like, no, fix that, but I didn't do any of that for this lesson, so that was kind of the purpose. Is just
cool.
So yes, but as teachers, we should definitely have the exemplar.
Awesome. So now part of I'm so glad you said. So now part of the procedure now is we know the standard. We know. I feel like I have a deeper understanding of that math standard. I hope all of you guys do as well. I also feel like I have this precision. We even talked about temperature and all those things. And the third one was just writing. We may not have a deeper understanding of that, but that's okay. Like, can you read it coherently is what we're saying. Right. So now that we're looking at these three, we should be looking at those standards. I would encourage you not to look at her notes or their notes at the top, but let's look at it deeply and start thinking about, is the kid attending to precision? Are we seeing the mastery of the standard and with writing as well? So maybe we could take 5 minutes where we do that. Would you guys be okay with that, or are we on the right?
No, you're fine.
Okay.
Marina, one more time, what's your system? UPT? What else?
Advanced, proficient, partially proficient, unsatisfactory. So proficient is what grade level.
Do you have something? Do you have proficient?
I have.
Partially proficient.
So if you can write a final question, but we need the statement 5 and 6. But that's a cultural thing. Yeah, and they put the dollar, the symbols in certain places. This was like, what? This is correct?
So there's no difference between advanced and just the number line?
The abstractness and then, correct, and then their precision.
Precision.
Right. That it's a clear writing. Because
Yes.
sun, you can tell who's ELL all
Yeah.
over right here.
Did you guys notice anything that you guys want to share out? Like,
So, I guess it kind of, we put this example up. This was just a pretty good example of where, how.
I mean, these scores are my opinion, right? So challenge me
yeah.
on any of the scores, but like.
This might be hard to read, but so this student used two of the word problem or two of the word bank. So she had, the girl ate 10 donuts and gained 4 pounds. I earned $10 for my mom and my uncle gave me 4, so now I have 14. So this was kind of the common trend is they know that they're moving 4 units from 10, but they think, okay, I'm adding, so I automatically increase. And so like, that was just one of the most common issues we had. There was
What do you teach them to like cover up the plus sign?
-4.
Well, so we just talked, the way we kind of taught it was introducing number lines to them, which is basic 3, let's start at 3, if we add 2, which direction are you going? So that they got the idea, okay, every time I add, because they've only ever been working with positive numbers, so that's where the assumption is I always just go to the right is. But then we're talking about adding a negative and how if you're adding negative temperature or if you add debt to your bank account, those types of things, are you increasing the amount of money or are you actually losing money? And so trying to get that adding a negative is the opposite of what you think, showing them to go to the left on a number line, which some kids have picked up on it, but again, we still find that a lot of students, which they've been doing to the right for the last 11 years of their life, that they haven't caught on.
it kind of goes to that deep understanding of this, because this kid, Layla, did a really good job. She wrote down, like in a context, John earned $10 babysitting today. Like he earned $10. Then she said he paid $4 for a video game. So how much does he have? Well, then she went to negative 14, right? But she has a deep understanding because you can hear it in her writing, right? He earned $10, but then he had to pay for a video game. So you can hear the 10 minus 4 right there.
Right, and so that's another good point. A lot of kids just added the 10 and the 4 to get 14, but there was a small number of groups, at least multiple, that I realized did the same thing as her. They said 10 plus 4, they still got 14. But what I'm thinking is they got confused about that negative, and so they just threw it in as negative 14 because they knew it can't be 14 if it's 10 plus negative 4.
That's right.
And then so they like got caught and just took a guess.
Probably because they are adding the numbers in the problem, but not in the equation, not in the expression. Because in the problem, the number 4 doesn't have a negative sign. So probably they're adding from the word expression from the problem instead of.
Yeah. That's why I think like this Layla, this is where I talk about this often, I think you guys will too as well, is there's this conceptual understanding. She conceptually understands how this works. But then to go through this negative, left, right, plot, positive, number line, like she's not getting that procedural piece, right? And so I was kind of looking through also with Jacob. Jacob, he wrote down, it's amazing, but he wrote, if you had a negative $4, then you owed somebody $4. Like he knows that. If I have negative 4, I'm going to owe somebody. Yeah. Conceptually, he's got that. Then if you ask for $10 more, since you already owe money, then add $10 to the $4 you owe, and that gives you a negative 14. Like He has it. Like he has it, but he's not doing the math procedurally correctly,
Yeah.
right? Which means he doesn't really conceptually understand it.
Yeah, look at this. This girl said, I got paid $10 and I had to owe $4 to my brother. Technically, she understood the sentence, but the operation was 10 plus -4, and her answer was -40.
40?
40.
She multiplied.
Right, so
Yeah.
like, not the reason.
Well,
Not even.
Which is what we were doing in class
she
that
multiplied
day, so maybe
well,
that's the confusion.
but wasn't
That's
the,
fine.
You know, so this is the part of our PLC where we kind of, now that we've identified a few gaps, do you hear them? Like,
Yeah.
we've narrowed down 2 or 3 gaps, and then we start thinking about our tier 1 instructions. So you're going to hear that from me often, like, what do I need to change for everybody? Maybe there's something I need to do. Or tier 2, like, I need to sit down with Jacob, right? Or I need to sit down with so-and-so. And that's where we get to this point of tier 1, tier 2
To
conversation.
go back to what Caitlin asked about, like, how did we teach this? Another way that we taught this, and I think this kind of goes back to what you're saying, how do we fix this, was use the whiteboard
Yep.
to show you. It's called the WAR method, and this makes a little bit more sense than moving left and right. So you have them just create a table of positives and negatives, and then I ask them, okay, so how many positives are in this problem? 10. How many negatives? And so they put 4 on the negative side, and then you say, okay, here's what your battle. Who's going to win this battle? Who has more troops? They say positive, and you ask, well, how many more troops do they have? So let's say every troop cancels out. How many extra troops will be on the positive side? And then that's where they see they get left over with 8 positives, and that's been helping a lot of students.
6.
Sorry.
No, you're referring to much math.
While we're on camera, yeah, 6. 6. So that's like another approach we've taken to teaching, adding integers. This tends to make a lot of sense with students. Just, okay, there's more positives than negatives, but if they cancel out, I'll end with 6 troops or units left.
That's such a good strategy. I wonder what other ways can help them conceptually understand, like what tangible ways. I have some few ideas, but I want to ask you, like, what are some tangible ways that we can help them understand this?
Drive.
Do you have
I really don't think it's the 10, it's not 10 minus 4, it's a plus and then a negative. I think that's the most confusing thing. But it has like colored chips. Green means positive, red means negative.
The chips, so the chips
Black
is what
and red.
CMP uses, the actual curriculum. And that's what I did with my students last year. What I found with that is it works great when you have more positive, so 10 black chips and 4 red chips, they just cancel out. That's very easy, but the issue with that is when you have to start introducing 0 pairs. And,
Can you give us an example of what that would look like?
a 0 pair.
Yeah, or because I understand when you have to like start pulling.
So if I do like 8 minus 10,
There you
I
go.
don't have 10 black chips. So they have to introduce 2 0 pairs, so 2 black and 2 red, and then they have to take the 2 black. It just like creates this big confusion of, well, why am I adding chips, 0 pairs? Conceptually, it makes sense to a lot of adults and the more advanced kids, but the chip method, just introducing 0 pairs and taking out, I found really creates more confusion than it does understanding. I found this year, between war and number line method, the kids, I mean, they're not proficient yet, but they are doing much better than my students did last year with this information.
What about like the, I think this is just the whole thing right there. So like 2 negatives, that's the same thing, positive, right? Kind of like.
You're looking right above your head is what you're looking at.
But that's multiplication.
Yeah, it is.
My teachers like taught us something like 2 negatives and a
For
positive.
subtraction, probably. So if you have like 3 minus -2, you can change it, and that's what we do is keep change flip. So the reason addition is so important is if they're stuck with subtracting integers, they can always switch it to addition to just do 3 plus 2. And keep, change it to addition, flip the sign. Because then they can, okay, that's 5. So that's why personally we've been trying to focus more on the addition piece.
So that gives them a very procedural understanding. Like as long as they remember that 2 negatives make a positive, they're fine. But it doesn't give you the conceptual understanding that is so important.
Right.
When I've so whenever I've taught negatives, I was really cautious about using that word negative. I mean, I would use it, but I used the word opposite a lot because a lot of students know the opposite of 2 has to go the other direction. And so if you switch it to that saying of opposite, it takes this away because they know, like, subtracting the opposite of 2, they know that they have to go further in that direction. And I've also done like number lines on the floor where, like, I put the number line and, okay, so we always face right. The right is how we always face. So every time I see a negative, that means I have to go to the opposite direction. So I have to turn around. And if I see another negative, I have to go to the opposite direction. And you get that understanding, plus they're moving. And that way, if they forget, wait, 2 negatives make a positive when I'm multiplying, or is it when I'm subtracting? When is that they can go back to that conceptual understanding?
We did do something very
so
similar to what
important.
you just described. It was a paper version. It was called Integer Man, and so the rules. So 8 minus 10. You would have a number line. You put your man. So you have a little paper cutout man, and he would start at 10. If you're subtracting, how did it go?
Facing you.
If you're subtracting, he's facing to the left, so integer man would be facing this way. If you're adding, he's faced to the right. And then if your second integer is positive, you move forward. So he's facing this way because it's subtraction, then I move forward, he walks forward 10. So if it were minus negative 10, he would still be facing to the left, but since the second integer was negative, he would then go backwards where it would be.
And this is exactly why what you guys are talking about is amazing, because the conversation all year you're going to hear from all of us is this procedural or it's conceptual? Right now we're talking a lot about procedural, and we're even having troubles explaining what we understand about procedures. I don't know if I've seen you guys catch yourself, like, is it left or is it right? And you're like, what the thing that we want our kids to know, 8 minus 10. If I have 8 and I got to take 10, I don't have 10 to take away. Conceptually, what do I have? Well, then if I have $8 and someone tells me I owe 10, I'm negative $2, right? That's what we want them to get to. And I think your data today showed